Hello everyone, how are you guys? I think echo is not a problem. Do we have echo right now? Okay, I don't think we have echo. So we are good to go. Awesome. So today we are going to learn about worker threads. Okay. And yesterday we discussed about asynchronous, async await kind of a things. And we are gonna build on that. So first we want to talk about why promises are not sufficient for everything. Like asynchronous programming is not sufficient in case of JavaScript, and the big reason for that is that we cannot really say that single thread would be able to satisfy for all the tasks. And what is the reason for that? If we have a single thread for doing everything, if we have something computational intensive, okay, we can delay the things so that nothing is getting stuck. But if we have the situation that if we cannot say, just 1 second. Yeah. So if we cannot say that you will not be at any point do you will not be able to do a computationally intensive task, then that's a big limitation, right? If we say that if you have a task that would take, let us suppose, a minute to complete, okay, that's that much computationally heavy, okay, and with the help of async, what you could say that I don't want to do it right now, I want to do it at a later point. Okay, but later when? Because at any time you would need some resources to do it, and your system would be stuck for that time, and we do not want to do that. Okay, so hello Gaurav Sharma. Hello Gaurav sir, how are you? Hi to you as well, love you to you as well, sir. Okay, so if this is the situation, then how we can come out of it, that would be the agenda for today's session. Okay, we'll start by the first step. That would be, let me share my screen. Awesome. So you guys are able to see my screen now. So we will start with the thought process of, Mhm. Yep. Okay. We'll start with the thought process of creating an express application where we have two endpoints. Okay. Awesome. Um, npm init, creating a node application empty. Cool. Empty application available. npm I express. Okay. Good to go. New file, index.js, const express is equal to require express. Awesome. Created an application app.get. We have a, like you can say, a small endpoint that would not need that much of resources. So for right now, small endpoint. Okay, awesome. And we have a big endpoint. Cool. So this big endpoint is requiring a big task from you. Okay, so like potentially you need to do something like this for I. Okay, we are not doing anything, but still a long running task, because first I would be 0, then 1, then 2. So it would take some time to complete it. Let us suppose we even increase the size for this and we run this. npm run start. And sorry, we haven't added the command for that, so let's just go with node index.js. Cool. And let's come back to the browser here. Let's take it here. Good. Localhost 3000 small. Sorry, we forgot to add to the port number. Listen, 3000. Console log server is up. Add port 3000. Good to go. We'll need to restart it. Small and big. First check. Yep. Localhost 3000 slash small endpoint. And when we say big endpoint, this is the situation I'm talking about. So right now we are stuck. Okay. And if we simply say that, okay, this is potentially async, this is async, that is not helping me at all, right? Because even though this is a asynchronous function, the first point from where we would be able to send the promise, then only we can take the advantage of it. But even though you're calling that this function is asynchronous, but still everything that's happening within this is synchronous. So you're not able to take the advantage of asynchronous programming in this sense. Okay, that you do not have a way of like solving this process just by saying that this is a async thing. Okay, cool. So if this is not possible, this is not the way you can do it, then how you can solve this scenario? Okay, like if I say this is big, we are stuck, and I say localhost 3000, sorry, small, cool. So just because we are able to say that this is available, this is still stuck. Okay, when this is resolved, only after that this would be resolved, because this process is stuck for this big task, it wouldn't be available for the small task. Cool. So do we have a easier way to do it? Yes, in case of JavaScript, they provided something, and the something right now is that you can create additional thread pool, the worker thread pool. That it's not same as multi-threading that we have in other languages, but it is quite similar to that. So you can take the advantage of it. And what you can do with that is you can potentially, there are two ways to do it. One way is a bit hard way, where you can create potentially you can say your own uh, with the help of uh, worker threads. So with the help of worker threads, you can create your own function for that. And second way is this worker pool. So with the help of this worker pool, what you will be able to do is you will be able to create your pool of workers, individual worker threads. You'll be able to create a pool of that. And now when the request would be coming, you'll be able to delegate those requests to these worker pools. Okay. So if we install this in our code, awesome. Worker pool available now. Const worker pool require worker pool, and creating worker pool created. Awesome. So now instead of this, let us suppose we want to do this task in our worker pool. How do we do this? We'll say pool.exec, and then what we can provide, what function we want to execute with this, and what are the dependencies for that. So let us suppose we create this function here, const work hard, okay, is equal to a function. Right now this function is as simple as this one. We do not have any parameters for this right now, but potentially this is helpful. Okay, still commented, this part isn't commented. Awesome. So we are doing this task, work hard, and this, and then when it is resolved, we would respond okay, big endpoint, and we are good to go. What is happening right now? Instead of sending our request, definitely we are still sending the request to our express, but instead of like managing this request here, what we're saying is that this execution right now is getting sent to a thread pool. kind of a worker thread pool. And now there would be a queue of it. And whenever we have this availability of, okay, so our worker pool is available to take a new task, it will be able to pick up the task, execute, and when the response is available to us, whenever we are able to resolve one, we'll be able to respond with that. But now the situation, how is it better than the previous thing? Because now if we do this and run this again, let's open the browser again. Cool. If we send this big request, cool, we should be stuck at this point, but still this is not getting stuck. Okay. And if you want to see this in action in the format of potentially a browser, so let us create a small code for that as well, potentially index.html. Okay, HTML5. Let's load Axios. Awesome. And here we have maybe an ordered list, ID list. And what we want to do here is we will make a list of requests. And whenever the response we receive for that, we'll be able to attach in a response to this list. Okay. So can we say we have list of URLs? Okay. Const list is equal to list of URLs is equal to awesome. We will create HTTP localhost, and maybe we can just copy from here. We are sending few small requests and then big request. Cool. So if we are not utilizing this, if we are not utilizing this, then potentially what we are saying is that instead of sending this request through pool, we are directly sending this request to work hard. Okay, we are executing this and then responding from here. Okay, and if this is happening, then potentially from here, for every request that we are sending, so we can say for URL of list of URLs, Axios dot get URL, then when we receive the response, we will create this list item, and the data that we are going to receive from here, that will create the list item in a text HTML, and then we will add this item in here. So let's create this outside. Const list is equal to document dot get inner HTML get element by ID, and this list is here. We are receiving this list, getting this object here, and now we are able to append item here. Awesome. List as a name is not so good, so potentially we can say list item or whatever you want to call it, or yeah, but whatever you want to call it. So good. We are ready to roll, and let's run this with the help of serve. Npx serve dot cool. Yeah, we didn't provide course policy, so this error will happen. So we have to go to the server, install course, because of cross origin request. Right now this port is different, that port is different, so we will need to install cores. And one great thing would be if we could say that potentially it is running on 8000, so our this error doesn't come up every time because server is expecting to run on 3000. But for this we will need to also change here, this becomes 8000. Awesome. So, and here we'll need to install cores, const cores is equal to require cores. Awesome. App.use cores. Up and running, up and running. Just saying 3000. We should have that change the text here as well. Cool. Okay, good. Now back to this. Instead of this, we can say 3000. Small endpoint, small endpoint. Okay. What's stuck? Network, big endpoint. So right now what we can see, whenever a big endpoint is coming, till that is not resolved, even the small endpoint wouldn't be able to successfully move from there. Okay, so what we want now is that shouldn't happen. It's not the responsibility of the endpoint itself to work for this. So if we come back to this here and say that it should be the pool doing this task, not we doing individually here. Awesome. And let's restart this. Come back. So now you can see that all the small tasks are not getting stuck and the bigger tasks are in pending because they would need still time from the backend to get complete. So uh, definitely we provided a pool, but the pool that we provided doesn't by default have a big size. So generally when we have more and more requests, so it generally append to that and then we get to the response of it. Okay, so we only take the benefit if multiple requests are coming back to back. So what you can see, that initial request, it was not taking the advantage of the pool. So request is starting, request ending, starting, ending, starting, ending. But now our backend got to know that the same request is coming again and again. So it increased the thread pool size, and now it is able to resolve multiple requests in a single go. Okay, so that is the advantage of using thread pool. First thing is you're not stuck anymore. Even though you have a computationally intensive task, you're able to complete it without getting stuck. Okay, and second thing is you do not have to worry about your server not responding if some request is in place. Okay, so it is very beneficial. Though there is one more thing that you can do, that is creating child process in Node.js. So this child process is even you can say a bit more sophisticated thing. So where you can say that thread is not sufficient for your work. You want something a bit more capable of doing a bit more things. So the managing data in between processes become a bit more difficult than managing data in between multiple threads. So that is a bit sophistication here. But in general, if you need a bit more computationally intensive task than your async can handle, you go for multi-threading or thread pool. Or if it goes further, like you have a bit more computationally intensive task for you for which you want child processes, you can even create that with the help of Node.js. So that was the session for today, and I'm hoping to see you guys for the session of tomorrow. We have some awesome projects corresponding sessions coming up. So see you guys then. Bye.